Okay, chemistry. So we're going to get into light and describing light with a couple of mathematical equations and trying to use that to understand things. But light is super important for chemistry because it's really our primary tool that we use to interrogate things and to understand what's happening at the really tiny atomic scale. And also it has effects, right? So you get to see because of light from the sun, but also you get to see at nighttime because of lights that we make, and how they work involves interesting chemistry that you'll be able to get your head around in this section. So first, a brief introduction to light. So light, well, yeah, we think of light as being the things that we can see, but that represents a number of a small section of the electromagnetic spectrum in general. So we can see visible light, but there is much more to it than that. We've also seen a few things already, right? So recall in looking at our nuclear energy that we had decay reactions. This is the decay of uranium-92, and this would produce a gamma particle. And that gamma particle, we said, is energy, but is also known as electromagnetic radiation. So the gamma radiation that happens from nuclear reactions and the light that you see coming from a light bulb have different sources that they come from, but what they are is exactly the same thing, and we're going to learn to describe that a little bit. So we call this electromagnetic radiation, and what does that mean? Well, it means that it has some electrical component and it has some magnetic component, and it kind of seems like those two push each other along until it can't go any faster. So those two push each other and you end up something going as fast as it possibly can in the universe, and the speed limit in the universe is the speed of light. So everything from our gamma radiation to the light that you see coming out of the light bulb to all forms of electromagnetic radiation going in a vacuum, that they travel at the same speed, and this is the speed of light.